All right. Lesson 2.7 is on applications. You know the end of the unit is near when we're talking about applications, and it is. We've got a couple of days left and then review and test, so probably very shortly you'll know when test day is and start preparing yourself accordingly. Applications, it's kind of weird to think of these rational functions as spots where they show up in real life, but applications isn't always necessarily real life applications. Sometimes it's just taking what you know and applying it to a new situation. And this is one of the types of questions that shows up in this section for applications, is this idea of, I know some stuff about rational functions, and I apply it to this sort of backwards question. I think we've seen one or two of these during the unit. Give the equation of a function with horizontal asymptote blah and vertical asymptotes blah. Well, the vertical asymptotes, we certainly know that that means the bottom, this is where these things are zero, right? So x is when x equals 0 is 0, and x plus 3. Now, how do I get a horizontal asymptote of y equals 2? Well, that means the top has to have the same degree as the bottom. This is degree 2 on the bottom, so it has to be degree 2 on the top. But then to get y equals 2, the leading coefficients, we have to pick off the leading coefficients, and they have to divide to be 2. So it would be 2 over 1, or we'd leave that alone and not even write that in there at all, and that would work. Is this the only function that would work to match this question? And the answer is no, because I could add any linear or constant term down here and it would still work. So lots of different ways to answer this application. Here we go. Ferd estimates that the revenue and cost functions for his lemonade stands are blah and blah, where X is the number of glasses sold, R and C are in cents, not dollars and cents. Okay, dandy. And we're asked to determine the average profit function, AP at X. Well, for profit, and we kind of have to lean on some business sense here, and I know there'll be people in class that have got an interest in going into business, but profit is just, you take how much money is coming in, your revenue, and you subtract your costs, and then that's your profit, right? So profit is revenue minus cost. Profit is revenue minus cost, and then I can do that little formula. And notice that this isn't a rational function at all. This is a polynomial function. So I get 8x minus 2x squared minus, watch your signs there. This is the profit function right here in decreasing degree. Oh, the average profit function. The average profit function, average profit is the profit per unit. Per unit. So it would, in this case, it would be per glass sold. I think this is often called the marginal rate, but I don't know much about business, so I won't say that that's what marginal rate is. You can ask Mr. Johnstone or whoever your business teacher is. The average profit is just the profit per unit sold. Profit per unit sold, which is that rational function. Done. Done. What's the domain? Well, we can see the domain of this thing. It's going to be defined for all values except for when the bottom is 0, right? So all we'd have to do is think of the bottom being 0. So for this function, we have x not equal 0. That's the, like, from the math point of view, it's defined everywhere else. But does it quite make sense for x to be anything? Right? Can x be anything? Does it make sense, for instance, for X to be negative? Can Ferd sell a negative number of glasses of lemonade? Well, probably not. For this application, X would be probably greater than, or we'd say greater than or equal to 0, but we know X can't be equal to 0. X has got to be greater than 0. Even further than that, probably there's some, because if it's just Ferd working, like could X be a billion? Is Ferd going to be able to make a billion glasses of lemonade? Probably not. There's probably some cutoff as X goes to infinity. Is that possible? And we don't know. We couldn't tell. That's a business question more than a math question. Also, what about fractions? Does it make sense that Ferd would sell a fraction of a glass of lemonade? Probably not, right? Can X be a fraction? Probably not. And in fact, probably we'd say X has to be a positive integer, right? We'd probably say X has to be a positive integer, a natural number, 1, 2, 3, that sort of thing. And how that's going to affect the rest of the question, we don't know. But this is the idea that when we have an application, we go from the math into, trying to think about what possible values we could have, and it is a little bit more difficult. Here we go. This is the main meat of this question. Find the average profit is greater than 2 and interpret your answer. Okay, so this is more like what we did last day or the day before, right? We want to solve that inequality rather. And so how do we get started? We solve the related equation. Equal to 2. Cross multiply as long as X isn't 0. And we remember what that means. That means that's going to go, X equals 0 is going to go on our number line. Equals 2x. I'm going to put everything on that side, so I get this side equal to 0. Minus 4x plus 1. Don't think this factors. All right, this doesn't factor. So that means there's no solutions? No. We're a little bit sad that it doesn't factor, but that means we can use the formula. A is 2, B is -4, C is 1. 4 plus or minus the square root of -4 squared minus 4AC all over 2A, which is bing, bing, bing on your calculator. Well, of course, if we were just solving an equation, we could probably leave it in this lowest perfect form. Well, this isn't lowest perfect form, but since we're solving an application, probably we need some decimal answers. And if you pound that into a calculator, you get 1.71 and 0.29 about. And those are the solution to the related equation. And once we get the related equation, we can put that on a number line. That's the idea. We got 0 where it's undefined, and in fact, on this side of the number line, we said that's not in the domain. It doesn't make sense for this application. And then we got 0.29 where that's not a solution because we want it to be greater than 2, so not a solution. 1.71. And now we want to use test points to find the regions of solution. So use test points. So in here, what would be a value that's in here? Well, we'd use 0.2, right, or 0.1 or whatever. So in there, 0.2. the left side and the right side. The right side we're comparing to is 2. The left side is that, Ferd's formula there, negative 2x squared plus 6x squared, or 6x minus 1 over x, and I have to just use my calculator. Unfortunately, I can't do anything but that, and it's no fun using a calculator, I realize, but, and you get that's about equal to 0.6, and so is the left side greater than the right side? Is Ferd making more than 2 cents per glass of lemonade here? No, right? That's not true. So that means this is not a solution. In fact, we should go on and do test points for the other 3 regions, but then we get only, and you should do this, of course. What would be a value in there? X equals 1, perhaps. This is a solution, and this is not. So my solution set is 0.29 is less than X is less than 1.71. There's the solution set. But let's think of this. Remember, this is glasses of lemonade, and we talked about how probably that this would have to be a natural number in here. So what's the actual, what natural numbers are in there? Not many, just 1. That's the only natural number that's in my solution set. And in fact, to make an average profit of more than 2 cents per glass, Ferd should make 1 glass of lemonade. That's it. 1 glass. Poor Ferd. Well, kind of a strange question, and strange that there's only that one solution. Poor Ferd, bad businessman, I guess. Notice that if I said, how many glasses of lemonade should he make to earn an average profit of $500 a glass? Well, there wouldn't be any solutions, and he shouldn't be able to have that many solutions. So an average profit of 2 cents a glass, maybe that's a decent amount. And if he lowered that, maybe per glass he only wants to make 0.1 cents, and then that would give the number of feasible solutions for him would increase if it wasn't such a high profit value of 2 cents per glass. All right, that's example 1. We got one more example in today's lesson. I'm going to pick that up in part 2.